Welcome to Maths for Economists. Today, we are stripping away the intimidation of calculus. Forget the power rule or chain rule for a moment. We are here to talk about the soul of economic analysis, the derivative. In economics, a derivative isn't just a formula, it's a sensitivity check. It answers the vital question: if I nudge this variable just a little bit, how much will the whole system react? Section 1. The concept of sensitivity. Think about Apple Inc. When they raise the price of an iPhone by $1, does demand drop by 10 units or 10,000 units? That responsiveness is what economists call elasticity, and mathematically, it is powered by the derivative. It is the measure of how sensitive one variable is to another. In a world of finite resources, knowing this sensitivity is the difference between profit and bankruptcy. Section 2. The speedometer of change. Imagine you are driving a car. Your position is the function. Your speedometer shows your derivative at that exact moment. In economics, we don't just care about the total cost, we care about the speed at which costs are rising as we produce more. If the slope is steep, your economic car is accelerating into a high-cost zone. If it's flat, you're in a stable equilibrium. Section 3. From secant to tangent. Historically, economists like Alfred Marshall struggled to define the instantaneous. If we measure change over a year, it's an average, but what about the change right now? By shrinking the interval delta x to almost zero, the secant line, which touches 2 points, becomes a tangent line, touching only 1. This is the limit, the foundation of the marginalist revolution of the 1870s. Section 4. Marginal utility and the law of the second cookie. Why is the first bite of chocolate amazing, but the 10th bite boring? This is diminishing marginal utility. The derivative of your happiness function is positive, but decreasing. Statistically, most consumer behavior follows this curve. As x increases, the derivative f prime of x gets smaller. This explains why we stop buying things even when we have money left. Section 5. Profit maximization. Why do firms produce where marginal revenue equals marginal cost, MR equals MC? Because the derivative of the profit function at its peak is exactly 0. In optimization, the sensitivity check tells us that at the very top of the mountain, the ground is momentarily flat. If the derivative is positive, you should produce more. If negative, you've gone too far. Section 6. The Laffer curve and policy sensitivity. Governments use derivatives to set tax rates. The Laffer curve suggests that at a 0% tax rate, revenue is 0. At 100%, it's also 0 because no one works. Somewhere in between, there is a peak. The sensitivity of taxpayers to rate hikes determines where that peak lies. If the derivative of revenue with respect to tax rate is negative, the government is actually losing money by taxing more. Section 7. Multivariate sensitivity, partial derivatives. In the real world, nothing happens in isolation. The demand for coffee depends on its price, the price of tea, and your income. We use partial derivatives to check sensitivity to one factor while keeping others constant, the famous ceteris paribus. It's like having several knobs on a machine and turning only one to see what happens. Conclusion. The derivative is the heartbeat of economic intuition. It transforms static snapshots into dynamic flows. Whether you are analyzing inflation sensitivity at the Federal Reserve or setting prices for a lemonade stand, you are performing calculus. You are checking the sensitivity of the world. References. 1. Alpha C. Chang, Fundamental Methods of Mathematical Economics. 2. Hao Varian, Intermediate Microeconomics. 3. Gregory Mankiw, Principles of Economics. 4. Gujarati, Basic Econometrics.